Hello, dear friends and my dear students of BE 6th semester Electrical Engineering. From long time, once again I came to here to present you before this algorithm. We will go through the numericals of fast Fourier transforms. Already you are aware with this. I am here, LALITKUMAR P. BHAIYA, Associate Professor, Electronics and Telecommunication Engineering Department, and in front of me you are the students of 6th semester Electrical Engineering students. Previously we have learned lot of about DSP, and you have also gone through the number of videos of the DSP. Also we have seen about the fast Fourier transform, the DIT algorithm and DIF algorithm also. But in that video we have not gone through the numericals of these FFT algorithms. Let us see the numericals here. Today we will discuss some variations and numerical extensions of the basic FFT algorithm, alternate forms of the FFT structure, computation of the inverse DFT, that is DIF, the decimation frequency FFT algorithm, FFT structures for DFT sizes that are not integer of power 2, and especially we will go for one numerical of the DIT FFT algorithm. We developed the basic DIT, that is decimation in time FFT structure, in the last video, but other forms are also possible simply by rearranging the branches of the signal flow graph, considering the arranged signal flow diagrams of the following panels. Last time we have seen this DIT structure with input bit reverse output natural. Before going to the numerical, I will explain you once again this DIT structure. Here you can observe these are the input side. This is divided by 2. This is called as decimation in time, and this is the frequency domain. Output DFT, X of 0 to capital X of 7, and this is bit reverse. You can observe this X of 0 here, X of 4, X of 2, X of 6, X of 1, X of 5, X of 3 and X of 7. So these 1, 2, 3, 4, the 8 bit input sequence is divided by 2, and we will get the 2 8 bit sequence, even and odd. So this is the 4 samples in the even sequence, and these are the 4 samples in the odd sequence. And this even 4 samples again divided by the 2. So we will get this first 2 even samples from the 4 even samples, and these 2 odd samples from the 4 even samples. These 2 are the 2 even samples from the 4 odd samples, and these 2 are the 4 odd sample from the 4 odd sample. So this is this sequence of these 4 samples. First these 4 samples, and again these 4 are divided into these 2. These next 4 is divided into these 2. So this is called as DIT algorithm, in which always for 8 points, capital N is equal to 8, period of 8 points, we will get the sequence at the input side as a bit reverse, that is 0, 4, 2, 6, then 1, 5, 3, 7. This is the sequence of even, this is the sequence of odd. 0, 4, 2, 6, 1, 5, 3, 7. And always remember, for 8-bit DIT algorithm, the input sequence always will be like this: 0, 4, 2, 6, 1, 5, 3, 7. Always in 8-bit. 16-bit it will be different. But at the output side, this is the frequency side, there will be no change in the sequence. This is from X of 0 to capital X of 7. This is the frequency output, that is DFT, capital X of 0 to capital X of 7. So while going to the numerical of this particular, you can observe here, this is the first stage, this is the second stage, and this is the third stage. In first stage, the two x of 0 and x of 4, these are the two lines shown here, and this is the cross multiplication. While after every each line, there is a twiddle factor multiplication, that is omega n 0, omega n 0, omega n 0, omega n 0 after each line. And at the same line, there will be a multiplication of -1 after developing this algorithm. -1, -1, -1, -1 after one line each. And this is the output of the first stage, this is the output of the second stage, and this is the final output. So by this algorithm, you have to simply get this output as shown in the figure. This output will be equal to this capital X of 0 here plus omega n 0 into x of 4. You will get here this output, capital X of 0 plus omega n 0 into x of 4. So this is the output. While here you will get the output here, this capital X of 0 minus omega n 0 x of 4. So you will get this out. Similarly, in this 3, you will get the output here. In the next, this is called as the simply flow diagram of the two sequence in the first stage. After first stage, in second stage, the first two sample will be cross multiplied by here like this, these two samples and these two samples. In the next 4 samples, these two samples are multiplied here and these two samples are multiplied here. So you will get the second stage for 4 samples, first stage for 2 samples. This is 2 sample, 2 samples, 2 samples, 2 sample, and in the middle stage, means second stage, you will get this 4 sample and this 4 sample. 2 sample are downside, 2 samples are upside, 2 samples are downside, and 2 samples are upside. And here you will get the output. But in this case, second stage, after every 2 lines, the twiddle factor is multiplied, omega n 0 and omega n 2. After this is 2 lines, omega n 0 and omega n 2. So these two lines will be multiplied, and you can get this output. This, suppose second stage first output is this one, is the output of this stage plus omega n 0 excuse me please, here this you will get here the output of this stage will be this output of this stage, this one, plus omega n 0 and output of this stage, omega n 0 into this stage. So you will get the output here. In numerical we will see this also. Similarly, the output of this stage will be output of this stage plus omega n 2 into output of this stage. And at this stage, the output is output of this stage minus omega n 0 into output of this stage. And the output of this stage is output of this stage here minus omega n 2 into output of this stage. So this type, directly you can calculate the output at this stage from this diagram. Similarly, you can calculate the output at this stage. And later on, at the final stage, that is third stage, these 4 samples and these 4 samples will be cross multiplied here. And after these 4 samples, you will get here the twiddle factor multiplication omega n 0, omega n 1, omega n 2 and omega n 3. And after these 4 sample, every line has a multiplication of -1. So here you have to multiply by -1. And in second stage, after every 2 samples, you have to multiply by -1. And at the first stage, after every sample, every line, you have to multiply by -1. One line, after one line -1, one line -1, one line -1, like this. Again, you can get the output. This capital X of 0 is the final DFT, and which is equal to this omega n0 into this output plus this output. Similarly, x of 1 is equal to this omega n1 into this output plus this output. Similarly, you can calculate this one. For example, this x of 7 is this output here minus omega n3 into this output. You can mark the output here. Let us say A1, A2, A3, A4 you can mark here. B1, B2, B3, B4 you can mark here, and simply multiply the twiddle factor and minus sign and get the output. This is called as the flow diagram, and this is the DIT structure. For n is equal to 8, capital N is equal to 8, it is 2 to the power 3 is equal to 8. Therefore, 3 stages are there. 2 to the power gets the stages. So 1, 2, 3. For capital N is equal to 8, we will get the 3 stages. And for capital N is equal to 4, 2 to the power 4. So 4 is the 4 stages. So we will get the 4 stages, 1, 2, 3 and 4 for 16 period, sample period. Capital N is equal to 8. So this is the basic flow diagram for the DIT FFT algorithm. In next video, we will go directly to the numericals. Here I can show you, I have got the pages like this. These are the pages which I have got for the numericals, and we will go for the numerical. You can observe, I will show you the numerical here in these pages also. These are the numericals. So in next video, I will explain you the numerical. Thank you very much for listening carefully this one, and I refer to go through the Dr. S. Sharma book for DSP for the more and more numerical. Also you can refer the Shalivahanan and this Dr. Mitra's book and Proyakis for DSP. Thank you very much. Thank you for listening. After this video, immediately we will see the numericals on this video in next video class. Thank you very much.